Hey everybody. Uh, so the two videos that you've watched were over what stereotypically are called double displacement reactions. Um, for us, they are called aqueous precipitation reactions. And then the video from yesterday was over the solubility rules. Now, for us, the solubility rules are going to change a little bit. Um, they are easier to understand with my method, but the video gave you a good foundation to build from. Now, the solubility rules are something that you will not have to memorize. Um, I have a printout that is laminated so that you can use it on tests and quizzes. Uh, and when we get back to in-person classes, you will get a copy of the solubility rules that I use. So today I want to show you a little hack to write precipitation reactions. Um, and we will uh, work on some example problems and learn when a precipitation reaction does not occur. So I'm going to share my screen and go through some example problems. So the first example that I want to go over, now this comes from a worksheet that you will get in the near future, but we have solutions of potassium, iodide, and silver nitrate. And we want to write the balanced chemical reaction for this. Notice that we are not given the products, we have to figure out the products. So a little hack that I like to do is I like to make a foursquare of each of my ions. So potassium is K, and it has from the periodic table a +1 charge. And then iodide is iodine with a -1 charge. And then silver, I go below my two ions in the first reactant and put the second reactant and its charge. So silver is a +1 charge. Nitrate, not nitride, but nitrate, NO3, -1. So using this hack, what you do is go across for the reactants. So K +1 and I +1 is Ki. And it says solutions of, I said solutions of, so potassium iodide is aqueous, plus go across for the reactants, silver +1 and the nitrate -1, that is AgNO3. I said solutions of, so that's aqueous. Now, to predict the products, using this foursquare, it's really easy. You notice that in the first video, they said the inner part of the reaction go together and the outer parts go together. That's true. But what happens is that your cation switch partners. So what you're going to do is this potassium is going to go with the NO3, and this silver is going to go with the iodine. Now, if you use your foursquare, though, you can just diagonally go across and write balance your charges. So potassium is going to be with the nitrate, that is going to be KNO3. And then the silver is going to be with the iodide to go diagonally across. And so Ag plus 1 and I minus 1 is going to be AgI. Now, from the video from yesterday, we know the solubility rules. We know that group 1 cations are always soluble. Nitrates are always soluble, so the KNO3 is going to be aqueous. And we know that group 17 anions, that is the halogens, are usually soluble unless they are paired with silver, lead, mercury, things like that, like transition metals. So the AgI is going to be a solid. Now, one thing that I forgot to mention is to balance this, but they are all +1 and -1 ions, so this ends up inadvertently being balanced. So let's see this a couple more times. We have the next reaction on the worksheet that you'll get in the near future is ammonium phosphate and sodium sulfate. So ammonium is NH4 plus 1. Phosphate is PO4 minus 3. Sodium is Na plus 1. And sulfate is SO4 minus 2. So go straight across for the reactants. So NH4 plus 1 with PO4 minus 3. You need parentheses around the NH4. It's going to be 3 chunks of NH4 and then PO4. And your reactants are always aqueous in aqueous precipitation reactions. And then the sodium sulfate is Na2SO4, aqueous. So then you go diagonally across for your products. So NH4 with plus 1 with an SO4 minus 2. You need 2 chunks of the NH4. So you put it in parentheses and then SO4 and then plus the Na is going to be, Na plus 1 is going to be with the PO4 minus 3. So that is Na3 PO4. Now, again, the solubility rules video from yesterday. Ammonium compounds are always soluble, so the NH4 2SO4 is aqueous. And then group 1, any compounds with group 1 cations are always aqueous. Now, this is a special case. We see that everything is aqueous. For aqueous precipitation reactions, in order for a reaction to occur, you must form a solid precipitate in your products. So you must form a solid. If everything is aqueous, you have a no reaction. And we'll look at why this is no reaction and subsequent videos, and hopefully we get back to in-person instruction soon. But for now, all you need to know is if everything's aqueous, it's a no reaction. We'll do one more of these. So we've got aluminum chloride. And sodium hydroxide. So again, you have to worry about charges and everything. So aluminum chloride aluminum is an Al plus 3. Chloride is Cl minus 1. Sodium is Na plus 1. Hydroxide is OH minus 1. So we've got aluminum with chloride for the reactant, so that's going to be AlCl3. And again, your reactants are always aqueous in aqueous precipitation reactions. And then you have the NaOH. Na is a plus 1, OH is a minus 1, so it is in fact NaOH. And then you've got to go diagonally for the product. So the aluminum is going to be with the hydroxide. Aluminum is a plus 3. Hydroxide is a minus 1. So we need 3 hydroxides. So this is going to be AlOH3 plus the Na plus 1, and the Cl minus 1 is going to be NaCl. Now, again, consulting the previous video from yesterday, the solubility rules, hydroxides, unless they are bonded to group 1 cations, are insoluble, so that means it's a solid. The AlOH3 is going to be a solid. And then we have NaCl. Na is a group 1 cation, and those are always soluble, so that gets an aqueous. Now I keep forgetting to balance. You absolutely need to balance everything. So we'll go ahead and balance this reaction. And we've got, to balance it out, we need 3 NaOH and 3 NaCl in the products, and that will balance out our reaction. So that's my hack. Hopefully that makes sense. One big key takeaway is that, like word equations, you do not worry about what the subscripts previously were. You worry about your charge balances, and then once you balance your charges, write all your compounds with the appropriate subscripts based on the charges. Then you go back and put coefficients in front of the compounds to balance out your atoms. So there is another layer to this. We will watch a video that is not me, but well, it's a YouTube video that we'll watch again. That's pretty quality stuff. There'll be 2 other YouTube videos, and then I'll come and supplement your instruction and reinforce some things from the YouTube videos. Hopefully we'll get back to in-person instruction soon, and you'll be able to do your worksheet after this video, we will do that worksheet that I worked from and took our examples from today. Um, if you have any questions, please email me. The best bet is to send me a message on Remind because that goes to my main phone and I get notifications on it. So, um, and it's more of a chat feature, uh, and it's a lot easier to guide you into um, learning through uh, Remind than it is on email. Um, but so far, that's all I've got for today. Thank you very much for learning with me today. I enjoyed learning with you.